I'm certainly very honored to be here. This is too loud. I'm certainly very honored to be here, to be with you, and thank you for this award, for which I'm most grateful. Now, I know what's asked of me is to give a speech, which I will do, and I hope you find it interesting. Now, this award recognizes me as a visionary in life science. Now, I do feel somewhat ambivalent about this recognition because in my mind, the word visionary carries the connotation that one can see into the future, that which has yet to happen. Since time immemorial, men have attempted to know the future. Those who profess to have such abilities, they are called the prophets, the sorcerers, the soothsayers. Depending on society's sentiment at the time, they would be held either in honor or in disdain. Even a great scientist such as Isaac Newton was no exception. Very few people know that Isaac Newton was consumed with the desire to figure out the biblical prophecies contained in the book of Daniel in the Old Testament and the book of Revelation in the New Testament. Now, obviously, his writing, and he wrote a lot on prophecy, his writing on prophecy never made it, quite successfully as his writing on mathematics and physics. But in contrast, there was a mystic prophet named Nostradamus who published his prophecies in the 16th century, and to this day his prophecies sell very well. And whenever there are uncertainties in the world, his readership will skyrocket. Now, we desire to know the future because human beings are inherently insecure. The future scares us because it is unknown. Fear rules the human race. Thomas Hobbes described man in primitive times as living in continuous fear of a violent death because life was solitary, poor, nasty, brutish, and short. While modernity has brought progress to man's material conditions, the modern man is no less fraught with fear. In describing the coming of the modern age in the 19th century, the English poet Matthew Arnold particularly pointed out that in the new world, there is no more certitude. This is a famous poem he wrote by the name of Dover Beach. The desire to know the future is therefore really an expression of the desire to be secure. It is part of the survival instinct of man, which produces that urge to know that which will happen in the future. Now, when it comes to my work in life science, I can assure you that I have no ability whatsoever of knowing the future. I never did, and I know I never will. If I appear as a visionary in that I carry out certain activities before they became mainstream, it was simply that I got an earlier start than most people in the biotech industry. I was at the right place at the right time and was prepared with the right life experiences to participate in the coming of age of biotechnology. Looking back on my life, these life experiences all seem no more than a constellation of random events. There were no grand plans as I came to fork after fork in my life. I simply chose what felt right at the time. It is only in retrospect that a pattern emerged. So calling me a visionary would therefore be an egregious exercise in historical revisionism. Such fictional narratives are all the more arresting when they are deployed to serve the purpose of aggrandizing those who have made good. Now, as a venture capitalist, we're in the business of creating the future. We invest on the promise of what exists in order to create what does not yet exist. Do I have only 5 minutes?
No, we want time. Sorry.
My fault. It's not my fault. Sorry.
I was told to give a talk for an hour. It won't be an hour. So venture capitalists are in the business of creating the future, right? So how then do people like us who do not know the future get engaged in the task of creating the future? How are venture investment decisions made? Now, why did I choose to invest in one project and not another? For those of us who invest in biotechnology, we are blessed as well as perplexed because we are never short of investment opportunities. Our problem is that we have too many choices. In spite of the tremendous advances in science and medicine, it never ceases to amaze me that we have not run out of unmet medical needs. As heroically as we are addressing some unmet medical needs, modern society has been hugely successful in creating conditions that add to the disease burden. I will come back to this point later, but for now, let me focus on investment decisions. I can assure you that in making my investment decisions, market size and drug pricing are never a concern in my mind. Estimating the profit potential of a drug is not an interesting place to begin. It is not that I ignore economics entirely. I do keep an eye on the financial viability of a drug to be developed, but only insofar as how that drug would fit into the practice of medicine in light of today's healthcare economics. I never do financial projection with spreadsheets. Such an attempt at predicting the future by making a series of arbitrary assumptions in the face of the unknowable is, in my mind, an exercise in futility. First and foremost, I consider my biotech investments as investing in science. I consider myself a scientist before I am an investment professional. An investment professional is guided by perceived profit, potential, and risk. In contrast, scientists are guided by nothing more than their curiosity. At least in an ideal world where science can be practiced in the absence of constraints such as budgetary or time constraints. Much of the progress in modern science came about, in fact, when science was practiced in such a way. The fact that I wear both hats of a scientist and an investment professional does not in any way compromise my belief that the practice of science should be curiosity-driven. Having said this, I would hasten to add that the curiosity of a scientist should not be a raw curiosity. If a scientist is equally curious about everything, I would question that his intellect is short of development. With learning and with exposure, a scientist's curiosity should be trained and shaped. This is why it is so beneficial for young scientists to be exposed to great minds. It is not, so to speak, a matter of acquiring knowledge from the master. Rather, interacting with great minds has the effect of shaping a student's curiosity. The way I judge a scientist is not so much by what answers he gives, but by what questions he asks. When I assess the quality of a training program, I look for how actively the students ask questions and the quality of those questions. As a venture capitalist, people come to me to pitch their projects in search of funding. Now, I listen to more than 100 presentations every year. My job is to ask questions. It is, of course, not possible that I'm an expert on the subject matter of all the presentations, and yet many people have said to me that I ask great questions and that they have benefited from discussing with me. So how do I come up to speed so quickly? Domain knowledge is necessary, but not sufficient. Incisive questions emerge from the placement of knowledge into context. So the maturation of a scientist is therefore the development of his context through the enrichment of his scientific repertoire and the sharpening of his ability to place new knowledge into that context. Now, what then is my context? I would describe my context by calling it a view of how life works. I know that such a sweeping statement carries the risk of being meaningless, but the vagueness is somewhat intentional. What I mean is that it's a sense and an awareness, and with it, a respect for the organizing principles of life. These principles are generally applicable to all life forms in the biosphere. In aggregate, they provide a general picture of how life functions. Some of these organizing principles are deduced from observations across the biosphere. I do mean the biosphere as encompassing all life forms in nature. We study worms, we study xenophis, zebrafish, Drosophila, with the implicit assumption that what is learned from studying these organisms is generally applicable to other species, notwithstanding the phylogenetic distance amongst them. The discovery of a gene in C. elegans or Drosophila guides us to look for its homologue in human. What I mean by organizing principle here are as much at the organismal level as they are at the molecular level. They are as much teleological as they are reductionist. Now let me give a few examples of what I mean by the organizing principles of life while keeping in mind or keeping in view some of their relevance to drug development. The first is the principle of redundancy. For life to exist, redundancy may not be necessary, but for life to persist in the face of constant assault from within and without, life must be organized with a certain degree of redundancy. It is no different from airplanes having to have redundant navigation or hydraulic systems. Going back to the early days of the study of nucleic acid, scientists were surprised to find that the codon code between RNA and amino acids was in fact degenerate, degeneracy being in the mathematical sense. This degeneracy is a form of redundancy used by nature to blunt the impact of mutations. Many proteins have isoforms that can be mutually compensatory, at least partially, for certain functions. In many biological signal transduction pathways, there is the canonical pathway and there is the alternative pathways. Some receptors can be activated either extrinsically or intrinsically, either ligand-dependent or ligand-independent. So drug development programs premise on inhibiting one pathway can therefore be supplanted by the redundant pathways. Along with redundancy, another principle by which life is organized for robustness is to have multiple levels of control. It has been fashionable to think that sequencing the genome will yield all secrets to life. Such a single-tier, one-way, linear view of how life functions is at best misleading. Like all well-designed systems, life must have multiple levels of control with feedback loops in order to be both robust and at the same time responsive to new input. Epigenetics in RNAs that serve control functions are ready examples of additional layers of control. Genetic diseases inheritable in a Mendelian manner but have incomplete penetrance offer another clue to multiple layers of control. Long thought of as oddities in genetics, the recently published study of 500,000 human genomes has given definition to this phenomenon of incomplete penetrance beyond family pedigree studies to the level of DNA sequence. It is not inconceivable that post-translational modification of proteins can act as a large last-ditch salvage mechanism when the genome fails. Besides being robust, the machinery of life is also economical. It is highly unlikely that the machinery of life carries a lot of excess baggage that serves no purpose. Rather than calling the large cache of non-coding DNA junk DNA, I'm more inclined to say that their functions have yet to be discovered. Admitting our ignorance is a more prudent attitude than calling nature stupid. With RNA, transcription of different open reading frames as well as alternative splicing are examples of nature's way of economizing information storage. When it comes to proteins, it is not uncommon to find a protein performing one function when it's located in one part of the cell and performing a totally different function when it is translocated to another part of the cell. Take the example of the protein cytochrome C. It functions either in the electron transport chain for making ATP or in the apoptotic process, depending on whether it is located on the inner membrane of the mitochondria or in the cytoplasm. Then there are proteins with multiple structural domains, each capable of effecting a different biological function. These proteins lend themselves to being the shared nodes in biochemical pathways and therefore creating overlapping network structures. Proteins like mTOR or AMPK would be good examples. They remind us that in drug development, the therapeutic window is not just due to the so-called off-target binding, but it may indeed be inherent to how life is organized and therefore unavoidable. Long before Silicon Valley invented the shared economy with services like Uber and Airbnb, nature has found ways to be economical. Symbiosis is another cardinal principle of how life is organized. Medicine has always treated man as autonomous agents in determining his health outcomes. The recent explosion of research on the commensal bacteria in the gut has upended this view of man. Experiments have shown that altering the composition of the gut microbiota can alter the mood and the behavior of the host, not to say its metabolism, immune system, and susceptibility to cancer. The deleterious effects of antibiotics overuse highlights the fallacy of this me versus them view between the human host and the bacteria in his body. The flip side of this is that the gut microbiota may offer a new avenue of therapeutic intervention for the benefit of the host's health. So one of the portfolio companies in our portfolio is attempting to co-opt the gut microbiota to promote growth in livestock in lieu of the use of antibiotics for that purpose. Let me use one more example in investment to further illustrate. In oncology, I never invested in kinase inhibitors, even though it was tantalizing that kinase inhibitors have finally overcome the bane of the therapeutic window which plagued all previous cancer therapeutics. Notwithstanding the alluring term of targeted therapy coined to describe the kinase inhibitors, I find the idea fundamentally unappealing on grounds that the more targeted a drug is for its target, the more pressure it exerts on the target to mutate and escape. The experience with both antibiotics and antiviral drugs attests to this. The ability to adapt is a fundamental principle of how life functions. To me, the efficacy of targeted therapies is necessarily short-lived. All the more as genomic instability is a hallmark of cancer cells. In expressing my reservation about targeted therapy, I by no means make light of the benefit of extending survival by a few months to those by these therapies offered to cancer patients and their families. I also grant that multiple targeted therapy can be combined to reduce the chances of escape, and as has been used in antivirals. While I truly applaud the development of targeted therapy and consider them as a major milestone in oncology, they are not where I chose to spend my time and resources. My proclivities in science are therefore akin to a taste, in the sense that some people like their wines sweet and other people like their wines dry. The people from Hunan like their food spicy, and the people from Shanghai like their food sweet. The strongest determinant of one's taste, in addition to genetics, is one's upbringing. My wife, being Cantonese, never had spicy food in her family while growing up, and to this day she cannot stomach any food that is the least bit spicy. On reflection, my coming to life science late in my studies played an important role in shaping my taste in science. Having changed my major so many times in my graduate or undergraduate and graduate studies, or in the physical sciences and engineering, I had sojourned across a rather large swath of the scientific landscape before coming to life science. My mind was therefore shaped to look at the big picture rather than minutiae. I try to look for generality when I encounter particularity, and subject any particularity to the test of generality. My mental habit is to map any scientific finding to the general picture of how life works, and thus to get a handle on its strength, its weakness, and the scope of its validity. My growth as a biotech venture investor is to a large extent the furtherance of the ability to abstract any investment proposal into a small number of cardinal features and to assess them against my context of the fundamental organizing principles of biology. It helped that I invested across different therapeutic areas, diagnostics and medical devices. This diversity provided a constant broadening of my context. In this light, I regret that PhD trainings in life sciences nowadays stress so much more the need to focus than the need to broaden. The explosion in the amount of scientific finding has ironically forced students to be more focused, lest the projects become intractable. Equally, the multiplication of experimental tools has shaped the student's mind to ask questions for which there is a tool designed to give ready answers. Tools have supplanted ideas as the starting point of a student's research. And finally, in the face of ever-tightening funding environment, the peer review system has the tendency of forcing grant proposals to be highly focused. Big picture, open-minded, and seemingly off-the-wall questions have become taboo. Such grant applications are dead on arrival. For applicants today, this blue sky has become the death zone. The safe thing to do Or rather, the only way to survive in science today is to ask small questions and not worry about the big ones. The system now favors incrementalism over bold, new thinking. These developments do not bode well for the future of science. In the last few years, investing in biotechnology has become fashionable in China. Tycoons who made their fortunes in real estate, in coal mining, in manufacturing, or in information technology have flocked to investing in biotech. I have heard these tycoons speak ever so confidently about their life science projects. Unfortunately, many of them were sold a bill of goods. I don't mean that those who sold them the projects are all charlatans. They may indeed be earnest about their projects, but those projects were conceived from very small views which were usually centered on the person's narrow expertise. More often than not, those projects turn out to be ill-conceived. Now let me turn to the point I made earlier of my amazement that we never ran out of unmet medical needs. As fast as we are solving them, we are also creating new ones. China never had a problem of childhood obesity as an epidemic, but now overweight kids are everywhere. American children used to grow up on peanut butter jelly sandwiches. Now warnings of peanuts have to go with any food that contains peanut as an ingredient. 1 out of 10 children in America under the age of 18 has asthma. The latest statistics show that in Korea, 1 out of every 38 children born falls on the autistic spectrum. 1 out of 8 American women will have breast cancer in her lifetime. 3 out of 5 Americans are on prescription drugs for chronic conditions, most notably medication for high blood pressure, high cholesterol, painkillers, antidepressants. Then there are all the new microbial pathogens from MRSA, antibiotic-resistant tuberculosis, to new viruses like HIV, SARS, MERS, chikungunya, bird flu, swine flu, Ebola, and now Zika. However one looks at it, whether in absolute terms or in relative terms, the human disease burden is truly mind-boggling. The gross health statistics mask another part of the story, and that is health inequality. In isolated pockets of high-risk areas, the incidence of certain diseases can skyrocket. I was in Chicago a few weeks ago and learned that the risk of children on the south side of the city getting asthma is 8 times the risk of children on the north side of the city. Not surprisingly, the south side is the poor part of the city, and the north side, the affluent. The epidemiological research of Professor Michael Marmot showed that the gap in life expectancy for men between the affluent and the poor neighborhood in the city of Glasgow in Scotland is a staggering 15 years. I recently attended a concert put out by the Glee Club of the historically all-black college in Tennessee. The lyrics of one of the songs make me think in relation to health inequality. If health was a thing that money could buy, the rich would live and the poor would die. A sense of social obligation to address health inequality is strongly behind some of my investments. A good example of this is the portfolio company named Matrovax, where we are attempting to use new chemistry to drastically lower the manufacturing cost of the vaccine against Streptococcus pneumoniae. Those of you that have children know that this vaccine costs $280 in the US. There is no way that children from developing countries or from disadvantaged backgrounds can afford it. And from time to time, there would be outcries in the Chinese press protesting the unaffordability of this vaccine by the average Chinese family. Because of the multivalency of this vaccine and its immunogen being polysaccharide rather than proteins, the cost of manufacturing is indeed very high. If we continue to make this vaccine in the same way of conjugating each polysaccharide to the carrier protein, the potential for lowering the manufacturing cost would be limited. And as long as no one has come up with a cheaper way of manufacturing this vaccine, Pfizer and GSK will continue to charge extortionary prices for this vaccine. Even though the biotech industry may never be able to have the same kind of low-cost disruptions as are commonplace in the IT industry, we should at least attempt to move incrementally in that direction. Because with IT products, cost reduction is business, but with vaccines, it is human lives. Science is value-free, but the social conscience, on the other hand, is value-laden. In the latter years of their lives, both Albert Einstein and Richard Feynman spoke eloquently on this dichotomy. If we examine the biotech industry from the viewpoint of science, we may beat our chests and gloat about all the novel products. Progress indeed has been great. But lest scientific triumphalism should get the better part of us, let us be reminded that in Greek mythology, hubris is at the root of tragedy. In the face of the unmet medical needs worldwide, we should stand humbled by how little we are able to do. I, for one, while having had the privilege of participating in many exciting scientific breakthroughs, am unable to rid myself of paroxysmal episodes of anguish. I anguish over the human condition, the social injustice in the world, and the feebleness of our work in alleviating human suffering. I bemoan the corrosion of unbridled greed to the disregard of human lives. It troubles me to see promising therapies not being developed because the drugs involved are generic and therefore perceived as offering no financial upside. All the while, when intellectual property is used as a license to set extortionary prices to milk the system. It troubles me to see promising science abandoned because of the lack of funding, while vast amounts of resources are wasted on politically motivated projects that are scientifically flawed. If I sounded pessimistic, it is because at times I am pessimistic. In this book, The Two Cultures by C.P. Snow, which was voted in Britain as one of the most influential books in the 20th century, the author described the disposition of scientists as fundamentally optimistic, while that of the humanist as fundamentally pessimistic. That pessimism is not without good reason. Humanists are not, as the Chinese would say, moaning in the absence of any malady. Any sober observer of humanity will not long be an optimist. Anyone who has looked into the abyss cannot help but be gripped by pessimism. I consider myself both a scientist and a humanist. As such, I find myself wandering to and fro between the two ends of optimism aroused by scientific breakthroughs and pessimism provoked by the human condition. The optimism gives me energy, while the pessimism imposes sobriety. The optimism keeps my melancholy at bay, while the pessimism keeps my exhilaration in check. I find this tension to be both necessary and healthy. Somewhere between this optimism and this pessimism, I have managed to find the enthusiasm to keep going all these many years. And somewhere between science and humanity, I still harbor the hope that my endeavors will yet bear fruit for the good of mankind. My journey would not have been possible without companions who share the same passion for science and the same commitment to social impact. With some of you, I have had the pleasure of collaborating. I appreciate your dedication, your creativity, and your scientific prowess. And I look forward to doing more together in the future. In education terms, as Ken said, we're all Dr. This and that here. We are all in the top 1% or 0.1% or 0.0001% of society. We share in this blessing, and we also share in the responsibility that comes with this privilege. Thank you again for having me here with you. I'm indeed very honored. Thank you.